For section 5.6, we are going to do the quadratic formula. And up until this point, I have shown you different ways to find the zeros, or in other words, to solve quadratic formulas or functions. And that is basically, we were just trying to figure out where that parabola crossed the x-axis at. And there was different ways depending on how the equations were set up. And now we're going to talk about this quadratic formula. And this quadratic formula works no matter what. So if you don't remember the other ways, or if they were difficult for you, this formula will give you the answers. So if you write this down, it looks pretty intimidating right now, but it's actually not too bad. So you just need to remember that when you're given a quadratic function, it's ax squared plus bx plus c. So you need to know where the a, b, and c values are to do this. So b is in front of the variable x. So in this case, it's a 10. And the formula says negative b out front. So we're going to put negative 10 plus or minus the square root of b squared. So that would be 10 squared minus 4. It's always 4 times our a value. There's not a value in front of x squared in this one, so it's a 1. And then times our c value, which in this case is a positive 2. And that's all going to get divided by 2 times our a value, which we already said was 1 in this case. So once we plug in those numbers, we can start simplifying. So we have negative 10 out front plus or minus. Underneath, 10 squared is 100, and 4 times 1 times 2 is 8. So we have 100 minus 8, so that would be 92 over 2 times 1 at the bottom, which would be 2. So then we can break that down a little bit farther. 92 is actually 4 times 23, so we think about this as 4 times 23. We can take the square root of 4, which would be 2. So the 2 would go out front, and then we would have square root of 23 left divided by 2. Now, this division by 2, I can divide that negative 10 out front by the 2, and I can also divide this by 2, the number in front of the radical sign. So negative 10 divided by 2 would give us negative 5, and then we would have our plus or minus, and 2 divided by 2 is 1, so we don't need to write that, and then we have the square root of 23 left. And those are our 2 answers in simplest radical form. We could use our calculator and find that to the nearest 10th or a 100th or whatever, but we can also leave it like that because that's the exact answer. There's no rounding involved. So now we're going to do this one more time. So I'm going to write the formula, negative b plus or minus b squared minus 4ac all over 2a. So again, a, b, and c. So there's nothing in front of the x, so that's really a 1. So it's already a negative 1, and we have to plug it in the formula where it says negative b. So that means it becomes a positive 1. And negative 1 squared minus 4a in this case is 2, and so is c. And then 2 times a is the 2. So if I simplify this down, I have 1 plus or minus. Negative 1 squared would be 1. And 4 times 2 times 2 would be 16. So I have 1 minus 16. So that would be negative 15 all over 4. Learned last week what we can do when we have a negative under the radical. That's an imaginary number. So we can do 1 plus or minus. We're going to take that negative out. It's like a negative 1. Square root of negative 1 is I. And then the square root of 15. 15 breaks up to 5 and 3 or 15 and 1, but nothing that I can take the square root of, so we're going to leave it as the square root of 15. And then we have 4 at the bottom. So we can leave it like that, or we can do the division. We have the division of 1 and 4, so that would be 1/4. And then we have plus or minus, and we have the square root of 15 over 4 times I. So that I would go right behind that fraction. So remember the number times the imaginary number, the I. So these are both the same thing. So either way you want to write it, I'm fine with either way. All right, the discriminant is just the part of the quadratic formula that's underneath of the radical. And if we plug in our numbers to just that piece without taking the square root of it, it will tell us how many solutions or how many zeros each quadratic function has. So if we plug in the numbers and we get a number that's larger than 0, and then we have two answers. If we get an actual 0, then we have one answer. And if we get a number that's less than 0, we have no answers. And there's pictures underneath to go with that, showing you what the graph would look like. So if there's two answers, we would have this here. If there's one answer, it's just sitting on the x-axis here. And if we have no solutions, it means it's not touching the x-axis at all, like what we have going on there. So we have to find the type and the number of solutions for each equation here. So remember, they have to equal 0, so I have to have everything on the same side. So I'm going to add 7 to both sides here so that I have 0. And then I'm going to do b squared minus 4ac. So b in this case would be a -6, a is 1, and c is 7. So -6 squared. So that would be 36. And then 4 times 1 times 7 would be 28. So 36 minus 28 would give me 8. So I have a number that is greater than 0. So that right here, oops, not there. I can't move it. This right here is greater than 0, so that means there's 2 real solutions. Okay, now moving on to this one, I'm going to have to add 9 to both sides. So I'm going to have x squared minus 6x plus 9 equals 0. And then b squared minus 4ac. b is -6 again. A is 1 and c is 9. So -6 squared is 36. And 4 times 1 times 9 is also 36, so that equals 0. And if we go back up to the chart where it actually equals 0, it says there's one real solution. So this has one answer. And then on our last one, we're going to add 11 to both sides. So we're going to have x squared minus 6x plus 11 equals 0. And then we have b squared minus 4ac. b is -6 again. 4, a is 1, and c is 11 this time. So the -6 squared is 36. 4 times 1 times 11 is 44. So that would give me an answer of -8. So that's smaller than 0. And if we look at our chart, if b squared minus 4ac is smaller than 0, there is no real solutions. So our answer here would be 0. And for our last example, it says the pilot of a helicopter plans to release a bucket of water on a forest fire. The height y in feet of the water t seconds after it is released is modeled by y equals -16t squared minus 2t plus 500. The horizontal distance x in feet between the water and its point of release is modeled by x equals 91t. At what horizontal distance from the fire should the pilot start releasing the water in order to hit the target? First, going to use the quadratic formula to figure out how long the water is in the air for. So to figure out how long it would take to hit the ground once it's released. So we are going to use that -16t squared minus 2t plus 500. And we're going to use the quadratic formula, so we have to do negative b. So 2 is already negative, so that's going to turn into a positive, plus or minus b squared, so negative 2 squared minus 4. A is negative 16, and C is 500 over 2 times A, which is negative 16. So when I simplify underneath of the radical, I get 32,004. And I get negative 32 at the bottom. And then when I break that into two different problems, when I do 2 plus the square root of 32,004 over negative 32, I get negative 5.65. And then when we do the negative 32,004 divided by negative 32, I get 5.53. So our time can't be negative, so it would take 5.53 seconds for the water to hit the ground once it's released. So now we're going to have to find the horizontal distance that the water will have to travel in this time. And that horizontal distance is shown right here in the picture at the bottom. So we need to figure out what that is. So they gave us the formula of x equals 91 times t. And now that we know that t is 5.5, we can do, or 5.53, we can do 91 times 5.53, and x would equal 503.23. So the pilot should release the water about 503 feet away from the fire.